Hello everyone, welcome to our channel. And a long time ago in a far away galaxy, I was once built the circuit. This is the circuit. Every time you press the button, LED turns on and slowly turning off. This is a monostable multivibrator. On the left side, I'm using transistor, and on the right side, I'm using 555 timer. The function of the two circuits is to serve as a timer. So let us see the circuit diagram of 555. This is a long time ago circuit diagram. 9 volts switch, 10K connected to pin number 2, pin number 1 grounded, 3 output LED, 470 reset to the positive supply capacitor 104. And then I have this electrolytic capacitor to pin 6, 100 microfarad, 16 volts. Pin number 7 connected to 6, 100 microkilo ohms. 100 kilo ohms connected to pin number 8 and to the positive. And this is a messy circuit diagram of our long time ago circuit. And also we have this transistor collector coupled monostable multivibrator. LED lights is controlled by the two transistors. And this is a previous circuit, and this is the circuit diagram. And now, since we are dealing with 555 timer, using as a timer switch, operating in delay mode of operation, I decided to build another circuit using 555 monostable multivibrator. Mode of operation in delay, time delay. And this is now our new module, an Arthropod module. This module is displayable. We have seen here the header, jumper, the power on LED, input LED, output LED, push button at the top. Also capacitor, some resistors, jumper wires, a base, a resistor, and a 555 timer located beneath the push button or under the push button. And this is capable of standing on its own. This is displayable. You can display this in your cabinet as a souvenir for electronics project building, circuit design. But the function of this is also a 555 timer monostable multivibrator or a timer switch, just like this one. So the function of this is not just like a monostable in PCB version, but it also functions like this. So let us see the function. If it's, let's connect the power supply to the 12 volts. Power supply of 12 volts. Let us now connect the other end. Where is that? This one. So let us now connect the negative to the negative. And now the circuit is powering on. The LED power on indicator is lighting. As you have seen here, circuit is on. This is good for display. At the same time, it functions as a 555 timer switch. operating in monostable multivibrator or time delay mode of operation. Now let us check if it works. Did you see the light? Input LED turns on every time you push the switch, and then the output LED is turning off slowly because of the operation of the circuit in delay mode, time delay mode. And also we can control this using this module, Arthropod. We can now control that by patching it, and we're going to use the patch through the pins of the header. Let us now patch the negative to the negative of the and then the positive. Let us see the positive to the positive of the okay. Now let us connect the positive to the positive of the output LED, and then we're going to use the header, jumper header at the side, slide it then let us see. As you have seen here, only the other LED is turning on because I put the header into the left side. I slide it into the other settings, but it controls the LED. So let us put again to the other side settings, push to. Did you see the light? Now let us again push. They are both lighting on and off. With the use of jumper header. So this is the Arthropod module operating in monostable multivibrator. This is good for display souvenir items. Every time you construct a project, you can put it in the display cabinet. Some sort of a fighter robot. There's a Gatling gun here, a laser, some sort of laser gun, a control, someone is driving the vehicle, and it's okay. So that is how to use the header for controlling the output LED. Let us now disconnect. As you have seen here, this is displayable collectible items. Looks like a robot fighter. There's a gun there, a driver, pilot of the robot. It is good personal items for collection items. Aside from being a 555 timer monostable multivibrator as a function, it also serves as a collection. Good for collection. So If you are still interested in building how to build this type of circuit, we now continue with our circuit diagram of this circuit. This is now the circuit diagram of our Arthropod, the schematic diagram. So in here you have the 555 timer, pin 1 to the ground, and then to the pin number 2, that is the trigger, is connected the R1 500 ohms, and also there's a switch to the ground with an input LED. Pin number 4 always positive, continuous supply to provide, and then the output is controlled by this header, and also the jumper header settings. When you set the output using the onboard output or the output outside output controlling, and this is the power on LED. This one I'm using 10 kilo ohms and 100 microfarad. Pin 8 to the ground rail, the positive rail, and connected it's in here to the header. 7, 6, capacitor 5. I don't use any capacitor here for control voltage, still okay. So that is the schematic diagram of our Arthropod module. You can build this using our schematic diagram, and this is the layout. As you have seen here at the top, the first push button, this is now our output LED input, and that is the 555 timer connected, inverted. And then we have this, the header, jumper header at the side, this one. And then the header serves as the feet or the base of the Arthropod. Also we have there the resistor, and that's the construction of the Arthropod. And now we can now see how it works by explaining the electron flow. If you're still interested in electronics engineering, how the circuit works. So this is now the new diagram. I'm using this 12 volts BCC. R1, I don't have the value of R1. We're going to compute for the values. Here, power on LED, I don't have the value of R2 here. I have the values of these two components. That is the controlling components that serve as the timer that controls the on and off of the LED. Pin 5, I don't use any capacitor, still okay. 6, 7 connected to the two components. And pin 4, the reset, always high to provide a continuous voltage supply. Pin 3 is the output. I don't have the value of RD1, we're computing that. And then we have this LED input, output LED. This is input LED. This is the power on LED. And this is the circuit diagram. And as we go along, we are now going to see this current flows once you power on the module. Let us again connect our Arthropod, a new model. Collectible modules. After building the circuit, you can display it into your cabinet display for collection. So it's only for collection purposes, because it's so hard to build this circuit, and if you don't have enough resources and time and experience in building the circuit, you will end wasting lot of components, killing lot of components in building this kind of circuit, because I wasted a lot of components upon building this circuit. As in comparing to the PCB, it is much easier and advisable to use PCB. The possibility of building a circuit, short-circuiting the circuit, is very big. Always short-circuiting the terminals of each component. And now let us now see the circuit diagram. If you're still interested in electronics engineering, so let us now see here. When you close the switch, now current flows into the switch and into the 2, pin number 2, R1 to R2. Now this is now connected here, and also pin number 4 and to the ground, also in here to 8 and to 6 to the capacitor, resistor, power on LED. As you have noticed here, when I connect the circuit, I mean the switch, I switch on the power switch, LED turns on. So this is now, we're going to compute for the values of the resistor here using KVL. VCC minus the voltage drop at R2 and D2. The required current for the LED to turn on is 20 milliamps or 0.02, and the voltage rating is 2 volts according to the data sheet. So in here, we're going to compute for the values using KVL, VCC, BR2, BD2, transposition, calculation, computation. We got 10 volts. The voltage supply across R2 using Ohm's law, BIR, transposition, and substitution, calculation, 500 ohms. We get now the value of 500 ohms to limit the current to flow in the LED. Now that's why the LED here is turning on. That is upon switching the power switch, the circuit switch. And also, when you switch on the power, this time, this is now, the circuit is now in a stable state. This means that the capacitor is charging through this path, R1 to pin 2, and then to pin 6, and then capacitor. Also in here, R to the pin A, to the R3, and to the capacitor. This time capacitor is charging. And also it flows to the grounding. And also we have this a reset line for continuous voltage supply. So this is the stable state. In stable state, since this our values to 10K and 100 microfarad, arbitrary values, I pick these values to control the circuit. The timing of the LED turning on and off by using these two components, 10K and 100 microfarad. Now the capacitor now is charging. Once you push the button, LED turns on and slowly turning off. That is now that serve as a timer switch. We can now compute for the delay computation using 1.1 times RC. We have now this value of 10K and 100 microfarad. Simplifying the term, we got 11.1 seconds. It seems that we don't have 11.1 seconds here because the jumper wires offers a lot of resistance. But still, this is the computation of what kind of delay, the delay you are going to design. What delay values you are going to design. 11.1 seconds. So when you switch on the button here, now this is now the current flows. 12 volts to the switch button, and then again to the ground, power on LED. When you switch on the button, this time capacitor now is discharging through this path. Capacitor to the pin 7, and also current flows into the R3 to this node to the pin number 7, and through the output. These two controlling the on and off of the LED using this formula. And since the capacitor is discharging, now we're going to compute for the values of the R1. When you press the button, the state goes from high level to low level. Current flows into the ground from logic 1 to logic 0. There's no current flows at the pin number 2. It goes to the ground, putting the circuit in logic 0. And we can compute the value of the resistor here using the KVL. Minus BR1, BED, or transposition, calculation, we get now this value. 10 volts voltage supply at R1. And then Ohm's law. We got now 500 ohms. As you have seen here, this is negative triggered edge pulse. It means you are applying a negative pulse from positive. When you press the button, becomes negative edge triggered. That is the meaning of negative edge triggered. And since we know the value of R1 here, 500 ohms, every time you push the switch, also the value here is 500 ohms. This time capacitor is discharging, entering in what they call quasi-stable state, temporary state, the discharging action of the capacitor to pin number 7 and to the output. What happened here is because of the discharging action of the capacitor tends to the LED to turn on with delay, turn off. So let us now see the current flows of the output. We're going to compute the value of resistor here to limit the current flows at the D1 or the LED, output LED. So let us now, using KVL, BCC minus BRD1, BD1, the same computation, 10 volts, 500 ohms. What is this I555 sourcing? So the 555 timer is capable of sourcing current of 200 milliamperes. This entering into pin 8, and now without a load, without this load, it enters to the IC and to the ground, and we can compute for the current output without a load. And we have this quiescent current, 10 milliamps, the sinking current of the 555 timer. This one. Without a load, you can compute that using this. Sourcing current is equal to output current plus quiescent current. The quiescent current is the current consumed by the IC, the internal current consumed by the IC or the 555 timer. Since we know the sourcing current minus the quiescent current, we got 190 milliamps. That is now the output current to the ground without a load. But with the load, we can compute that using this formula. Current output to the load, pin number 3, is equal to IQ plus ID1, IQ quiescent plus the load current. As you have seen here, output current IQ here is 10 milliamps. Output current is 10 milliamps plus 20 amps, which is 30 milliampere. Since the required current here, we know that is 20 milliamps, and the output current is actually outputting 30 milliamps. But because we have quiescent current here, 10 milliamps, so 30 minus 10 equals 20 milliamps of current. All current goes into the ground, the other currents. In here we have now the actual values. R1 500, R2 500, then R3 10K, C1 100 microfarad. We have no, in 5 we have no capacitor here connected to positive, grounded, 500 ohms, and we have this input LED, now 500 ohms. This is the timing diagram, and this is negative edge triggered. What it means is we have the 12 volt supply as denoted by this line. With the help of this R1, it produces a positive voltage supply to the IC. So this one is the 12 volts, this line 12 volts. Once you push the button here, current flows to the ground, short circuiting. So this one now is the action of push button. That's why they call it negative edge triggered, putting the circuit to the ground from logic 1 to logic 0, logic 1 to logic 0, or in voltage level 12 volts to 0 volts. Every time you push the switch here, this triggering pulse, the push button here is the arrow. That is the trigger. And it has an output. Every time you push the switch, LED turns on and slowly turning off. So this one, from 0 to 1, the output means the 0 or off state of the LED. Now it turns on the LED, then off again once you push the button here, and then again it's on, then off, and then push the button again, on, and then push the button off. That is the output in pin number 3. Output, that is what they call the timing diagram. As you have seen here, the duration of the waveform is equal because that is the action of the LED, the light of the LED. Always. Only the triggering pulse is different, the duration of triggering pulse. Applying a triggering pulse, or every time you push the button. Now we have this 500 ohms, 500, 10K, 100 connected to the header, jumper header, this header, the base, 500 ohms, LED output, input LED, switch button, grounded, pin number 2, R1, and this is the layout of our Arthropod module. That is now our new module. Collectible items, it is good to display, although it's so hard to construct. But still, for me, PCB is still the best because it is convenient to use PCB. But for me, I decided to build this one. It's challenging. And in the near future, just stay tuned to our channel because we're going to build more Arthropod version of the circuit aside from PCB type. That is the operation, how the monostable multivibrator works, the action of the capacitor and resistor will produce this delay timer in the circuit. Slide again. Okay, it is seated. That's our Arthropod Module. PCBLS. Thank you and bye bye.